What do a precious sparkling diamond and the graphite in a pencil have in common? They are both composed of the fundamental chemical element in living things, carbon. The carbon that formed diamonds got heated and pressed within the earth into the hardest natural substance in the world. The form of carbon you probably are more in touch with is one of the earth's softest natural minerals and a much less precious commodity, graphite. Blend it with clay, embed a filament of that in wood, and out pops a pencil. About 1,720,000 of them per day at this factory. The economics of production and sales can sometimes be shown by polynomials. We'll apply such a model to pencil production and sales. Suppose graphite were in short supply. As more pencils were produced, costs for materials, and therefore the cost of production per pencil, would increase. Suppose for any amount of pencil production in a day, it costs the factory $30,000. Those are its fixed costs. Beyond that, production of each pencil costs 5 cents, plus another 38 billionths times Q if Q pencils are produced. 38 billionths times Q is the increased cost per pencil due to the shortage of graphite. The cost of producing Q pencils, then, is represented by this expression, 30,000 plus Q times the cost for each pencil. The cost for each is 0.05 plus 38 billionths times Q. Expanding the expression results in this cost function for the whole production run. If the pencils sell for 18 cents each, then the total revenue, the money the company gets from the sales, can be represented as 0.18 times Q. Here's a graph of these functions. Notice that the revenue exceeds the cost for a range of values for Q between about 250,000 and a little over 3 million. That's when the company makes a profit. In fact, profit is the difference between revenue and cost. So the company's profit from selling Q items is this. Profit equals negative 30,000 plus 0.13 Q minus 38 billionths Q squared. The graph of this function is the difference between the heights of the revenue graph and the cost graph. This curve is above the horizontal axis in the range of values of Q, for which the company makes a profit. Elsewhere, it's a loss. But now it's easier to identify the number of pencils manufactured and sold that will make the company's profit the greatest. You can see that the company makes a maximum profit of $81,200 when it sells 1,720,000 a day. Whether a company is selling expensive jewelry one piece at a time or huge quantities of inexpensive pencils, it's all about making a profit. And polynomials can be a useful tool for projecting future earnings.